All right, ladies and gentlemen, I apologize for not being there today to finish this up with you, but I decided to go ahead and make it just an ed puzzle. I'll go through the rest of the slides talking about ionic bonding. There's a couple of things that we want to cover when we're talking about ionic bonding. Um, and so as you do this on Ed Puzzle, some of the practice problems will just be questions on the Ed Puzzle for you to do and answer those. I'll also give you an opportunity to ask questions and I'll respond to them after I come back next week. Um, yeah, so let's go ahead and get started. So the first thing I want to go over is some of these exceptions or modifications to the rules we talked about is called special metals, or they're not actually called special metals. They're called variable charge metals because they have different charges. We talked about how the transition metals, with the exception of silver, which has a +1 always, and zinc, which is a +2 always, some of the metals can form different ions with different oxidation numbers. So for instance, here we have iron 2 and iron 3. So you can see iron forms a +2 ion. Also, it can form a +3 ion. And so the way we specify the difference is when we name the compound, we would say iron and then put in parentheses the um, Roman numeral of the charge. So in this case, you would have iron and then in parentheses the Roman numeral for 2, and then iron in parentheses the Roman numeral for 3. So that's how it changes how we name it as well. So we would name the cation, which is iron, and then the Roman numeral 2 or 3, and then the anion. And so I'll give you an example of how we do this in just a second. Um, but I wanted you to just know these metals exist. You don't have to memorize this list of metals. I would provide you with the possible um, variations of the oxidation numbers for each of these, okay? So no, you don't have to memorize these. Just know that these are the common ones that you're going to see. So there's chromium, iron, cobalt, copper, tin, mercury, and lead. All right. So I'm going to give you an example of how to do this, going from the name to the formula first. So I'll do number one, and then you guys on this ed puzzle will do numbers 2 and 3. All right. So we have chromium 2 chloride. That's how we would call it. We call it chromium 2 chloride. That tells me that I have chromium and chlorine as my um, elements. So chromium and chlorine, I know that chlorine, because it's in group 7A, has a charge of -1 or 1 minus. Chromium, I look right here at this number, Roman numeral 2, that tells me that it's got a charge of +2. And now I can just use the crisscross method that we did before, where we switch the numbers, the oxidation numbers become the subscripts of the opposite, right? So the cation's oxidation number without the plus becomes the subscript for chlorine, and then the chlorine's oxidation number becomes the subscript for chromium. And of course, we drop the pluses and minuses in this case. So what we end up with is the formula CrCl2. All right, so it's the same crisscross method, except now we're getting this charge from the Roman numeral. So we're going to take a second, and I want you to do numbers 2 and 3 on Ed Puzzle, doing it the same way: tin 4 oxide and iron 3 oxide. All right, now there is going to be a time where you're going to need to determine the charge of the metal. You're going to be given the formula and you have to determine what that charge is. So to do this, to determine the charge of the formula, we have to remember that the sum of all of the charges of the cation and the anion are going to be 0. So if I know that all of the negative charges and all of the positive charges will balance out to be 0, then I know I'll be able to find out what my charges for my cation and my anion will be. So for instance, I have FeCl3, right? So I know that Cl is a 1 minus and that I have 3 of them because the subscript is 3. So if I take a 1 minus and multiply that by 3, I get 3 minus as a total overall charge for the chlorines. So if chlorine is 3 minus and the sum of all of the charges is 0, then iron has to be a 3 plus. So what does that tell me? Well, that tells me which form of iron I have. Remember when I said there was iron 2 and iron 3? This is iron 3. So the name for FeCl3 would be iron 3 chloride. Notice again the 3 in parentheses in Roman numerals representing the oxidation number for the iron ion. So I'll do one more example. I have lead chloride, right? PbCl4. So I don't know what form of lead I have. Lead has multiple forms. So I don't know what the charge is for lead, but I know that I have one of them. I also know that I have chlorine, which is a 1 minus. So I have 4 of those. My overall charge for chlorine is going to be a 4 minus. That tells me that the overall charge for lead has to be a 4 plus. And since I have one of them, 4 times 1 is going to be 4, right? So it's going to be 4 plus for my charge. So therefore, lead is going to be lead 4 chloride. All right, one more time. I don't know the charges for lead, but I know I have one of them. I do know the charge for chlorine, which is going to be a -1, and I have 4 of those. So multiply 1 minus 1 minus times 4 is a 4 minus. And I know that that means lead is going to have to be a 4 plus, and that'll mean it's a 4 plus here. So this is lead 4 chloride. All right, so you try the next 3. Give me the names of PbO, Cr2O3, and FeN. All right, any questions? So right now I'm going to give you an opportunity to put a question in, and then when we come back, I'll answer those questions that you put in here in class. All right. The last thing we want to talk about are something called polyatomic ions. Poly means many, right? A polygon has many sides. So we're talking about polyatomic. They have more than one atom in the ion. So some of these ions are going to be composed of these multiple atoms. You can see the table here on the slide is a list of all of the polyatomic ions that we're going to be concerned with. There are a ton more, but these are the important ones. All right. When we have a polyatomic ion, we're going to treat it as one unit. You're never going to change what it's written as here. So for instance, the acetate ion that's here is always going to be written as C2H3O2. All right. Now, if we need to have a subscript, we're doing the crisscross method and we need to put a subscript at the bottom, then we take the whole polyatomic ion and put it in parentheses like you see here. So this is magnesium, which you would have a oxidation number of 2 plus. So you would need to have the 2 at the bottom with hydroxide. So you can find hydroxide, let's see, right here, hydroxide ion. All right. So that's an OH minus. So if you do the crisscross method, you would need a 2 down here. So because this is polyatomic, because these two things, O and H, are together, we want to make sure we put them in parentheses before we put a 2. This is different. What this tells me is I have 2 OHs. What this tells me is I have 1 O and 2 H's, which is not correct. So always, always, always put the parentheses around the polyatomic ion before you put a 2. Otherwise, it's the same process. We go over the same crisscross methods, okay? One thing I do want to point out, you'll notice that almost all of these polyatomic ions are anions. They all serve as a negative charge. The only one that is not is ammonium, all right? Ammonium ions are positive, so it's the same thing, though. If you're going to have another subscript here, you need to make sure you put the whole thing in parentheses before you put a subscript. So let's take a look at how we do that. So I've given you 4. I'm going to do the first one, magnesium nitrate, which is one of the components of fertilizer. All right, so I can look up magnesium and know that that's going to be a +2. And I can look over here at nitrate. So this is nitrate. Be careful that you don't use nitrite. Okay, so these are 2 different ions. Nitrate is NO3, nitrite is NO2. Same thing with sulfate and sulfite. But here I'm going to use nitrate, NO3, and it's a 1 minus. Remember, just because they put a minus, there's a 1 there. I like to put the 1, just my own personal preference. All right, so now I'm going to do the crisscross method, and this 2 is going to come down here. But I need to first put this whole thing in parentheses. So what this ends up looking like is Mg parenthesis NO3 close parenthesis 2. All right. So the 2 is going to come down here, but you need to have a parenthesis between the 3 and the 2, indicating that you have 2 NO3 ions. All right. So do the same thing. You can do it on a scratch piece of paper and then put it in your answers for this portion of the Ed puzzle. For Tums, which is calcium carbonate, the poison potassium cyanide, and Windex, which is ammonium hydroxide. That one's going to use both cation and anion are both polyatomic. All right, so now we're going to go with the names. How do we name it? It's the same idea. All right, as before, we're just adding one little thing. So here I take SO4 and I can look up SO4, that's sulfate, right? And I can see that it's a 2 minus, so I put a 2 minus, and I have one of them because there's no parenthesis with a number on the outside. So I know that SO4, there's only going to be one of them, which is the 2 minus. And I have lead. Now, I don't know what the charge of lead is because lead could be 2 and it could be 4. But I do know that since I have one of them, and the overall charge, this should actually be plus, I apologize. This is a plus, not a 2 minus. Should be 2 plus, that's going to cancel out. So what we need to have is a 2 plus here. All right, so that means the name for that is going to be, oops, I didn't put the name on there. The name for that is going to be lead 2 sulfate. All right, so I would write lead, parenthesis, the Roman numeral for 2, and then sulfate. This is how you know that I'm not feeling well. I completely left out the name, which is the answer for this one. All right, so you have 2 of them down here, FeOH2 and NH4NO3 for you to do on this portion of the Ed puzzle. All right, this is it. This is the last part. Again, if you have any questions, you can put them in here. And again, I will go over them on Tuesday when we come back. Also on Tuesday, you're going to have just a short quiz on this, real quick, 4 or 5 questions, just testing to see if you understand how to do these things. All right, so that's it. Again, I apologize for not being there today. I wish I could be, but I will be there with you all on Tuesday. Have a good weekend, everybody.